Good afternoon. So my head's spinning a little bit after John Kemp this morning, for one thing. He got me thinking a little bit different on some things, but I like it if you ask questions to a point. You know, we can't, like he talked about the wormhole, some people he's talked about rabbit trails or rabbit holes. We can't go off too far, but so may speed it up if it gets too far off. But if you don't ask any questions, I'm going to ask you questions. And there are a few questions I'm going to ask anyway. So we make it interactive as a small group. If anybody feels like they're having a hard time seeing or there's not a lot of reading you have to do. Most of it I'll explain, and the words might not be exactly the same as what's up there. But if you want to move closer, you're welcome to move closer. Can everybody hear? Can you hear in the back? Does that sound good? Okay. All right, good. So yeah, this is about livestock and how do we incorporate livestock into the system, why we should do that. Can anybody tell me which animals, which panel of a picture are the Kentucky animals on there? They're all from Wisconsin except one is Kentucky. Yeah. You got it. Do you know the person who is? No. Okay. Well, we were talking about, there was a conference several years ago where they had anyway, you there where they had the roast hog for, yeah, that was good. Yeah. And I'm not sure if they came from this farm, but they certainly knew the people, I think it did come from this farm, I'm pretty sure. So this is what I want to talk about today. Just the idea of connection, community, holism, holistic thinking, how that ties in with health and disease. And then, the whole focus was why livestock role, what they do. Soil just is something that, John got into parts of it today, and he would just catch himself at some points, and he just had to stop because there's so much complexity, there's so much detail, there's so much going on that it's hard. But it's really important to appreciate its role, and that it really is the foundation. It's the foundation of all health, is the soil. And so if we want to have healthy livestock, we got to have healthy crops, and we got to have healthy soil to get there. So that's important. We'll talk about that. And really, my thinking about soil has changed over the last while from more of thinking about the balance of minerals and stuff to more about the life in the soil. And John talked about that quite a bit, about the microbiomes and things like that. So as far as the vet-related topics in here, grazing in relation to parasites, and John did have one slide about parasite control, about how it's going to be important to not have to use dewormers, and I'll talk about strategies that we use for that purpose. And then also about fly control, because fly control on organic farms is a big issue, and especially the further south you go, the more flies can be an issue. We'll talk about that. And then wrapping up, kind of trying it together with biodiversity and why biodiversity is important, how it promotes health in the system. And back to the whole thing about health and disease and resistance. But again, questions, if you have that during the time, just bring them up. So as far as health, the word health and holism, Wendell Berry, you're all familiar with Wendell, I'm sure. And in the Unsettling of America, the first book I read by Wendell, there's a really interesting part about health. There's a part about health, and he talks about the fact that the word health comes from a family of words that mean wholeness. The word whole, the word holy, those are all healthy, those are all in the same category. So it really, when we have something that's not healthy, things are not working together. We don't have all the parts working together. So that's really what we should be working on. And another man that I learned a lot from, and he's gone now. Any of you remember Jerry Bernetti? You've heard Jerry? Yeah, okay. So Jerry taught a lot to a lot of people, and his last book was The Farm as Ecosystem. And the book ends with this quotation from Thomas Berry that says the universe is a communion of subjects, not a collection of objects. So our tendency as people is to always categorize, separate, put things in buckets and say, this is this is that, label. And the truth is, it's not always so clear cut as to where the division should be, or even where one thing starts and another ends. And so it's really about the interaction between things. And we'll talk about this more later, but it's about how things move with each other. It's not just how, so in order to think about things, we make stop pictures of things at one moment in time, but in actuality, things are moving all the time. So community, that's the really important thing, and I really appreciate community, like the tour we had yesterday. A lot of the Plain folks have really good communities, the organic community. All these communities working together. Again, the wholeness, the connections, and really the cooperation between people. And how many were you on the tour yesterday? And so, had you been to coffee before, to the mill? Yeah, okay, I had never been there. I knew about it, but never had been in it. And the thing that strikes me about that, it's really impressive how much they've grown, how fast they've grown, and how much is going on there. But really what's striking to me is the people working there. And I think the people working there, it's obvious they care for each other. And I think that is a community-based business, which is different than a business that focuses on just making money. And so I think part of the reason that mill is thriving is because of the people and the relationship between the people and their relationships to the greater community. So I think this idea of community extends, we always think about it as people, but it's not just people and community, it's nature, it's our livestock, it's the land we live on, it's all about community. And so in particular with disease, John Kemp said this morning about the presence of a organism doesn't mean that a disease-causing organism doesn't mean there will be a disease. And he actually said he doesn't like this term pathogen anymore. And so pathogen is the bug that we think about causing the disease, like the virus or the bacteria that causes the infection. And really, it's not just the presence of the pathogen, it's the immune system, it's whatever the pathogen is going after, it's that state of health determines whether disease is going to happen or not, in part. But it's also the environment, and those things all work together. And so you can draw this a couple of different ways. And you can think about if it's a really strong pathogen, it's going to just make the triangle bigger. There's more chance of disease. It's pulling out that way. If you have a dirty environment, you're going to be making more chances for disease. A host that's not very resistant would be the same problem. Or you could talk about how big this area where the overlap is. And so if we had a strong pathogen, it would push in more, or a weak host, or a bad environment. And so you all understand just basically how that would work. So those things work together. We need to not think about disease in isolation. We need to think about it, how those things interact. And what we can do. What can we do to make the host stronger? What can we do to make the animal, the plant stronger? And that's what John was talking about. If you get these plants where their health is so good, the insects don't want to attack them. All right, so why are we here? Why have livestock? This is your question. Now, why do you have livestock? How many have livestock? Okay, good. Why do you have them?
Because I like them. My favorite thing to eat.
Good. Food. Yes. We like them. I agree with you. Yeah. And what else? There's got to be more.
They make money.
They what?
They make money.
They make
Money.
Yes, economics, of course. That's a very basic reason. Yeah. Anything else? Yeah.
They help manage our farm.
Yes, they help manage the farm. That's right. And so, what do we talk about? What's the foundation of health?
Soil.
What do they do to the soil? They should help it. Yeah, it depends how you manage them, of course. But yeah, that's another big part of it. The soil. Anything else? So these are. I think you mentioned most of these things. And Irvin, the last thing you put it up first, and I put it separate because to me that really is important. That we enjoy what we're doing. And so I think that the beauty, the companionship. I think that's a good. But cash flow, economics. We can diversify our operation economically. We're not so dependent on one market, for one thing. Biologic diversity. We're going to talk about diversity and how that's important for making health. Animals are a really critical part of the system, especially grazing animals. We talk about we want to make healthy soil. nutrient flow and recycling. So somebody talked about managing a farm, and it kind of takes those two things. You can influence what's growing by using, you can move the animals and have them graze something down. I think about these, you have these contractors that have goats that they go to places to clear weeds out and things like that. They actually charge for it. But you can do similar types of things on your farm, where you can influence where the hedgerows are growing or whatever. You can influence the vegetation. The animal impact, some people use that word for soil, how the manure and how the animals been. We saw a really good example of this on Wednesday. That was Wednesday, wasn't it? Yeah. And at Irvin's farm, and he does bale grazing in the winter. And you guys do bale grazing out on pasture? If you really want to build soil, organic matter and life, is get those cattle out there with bale rings, and you've got to manage it. You've got to move them. You can't, let them make a mud hole there. But that animal impact and the fertility that they put in there between the wasted hay, and it's not wasted because it gets recycled, and the manure and the urine from the animals, which Irvin talked about some hillsides that were broom sedge, that were really solid broom sedge, and now they're nice grasses. And he seeds some clover and things in there too to get it going. But the animals really make a difference on getting that land going, that pasture. So I worked mostly in dairy. And when I first started working organic, I started to think, what's different about organic cows? Because when people were looking, when organic was growing fast, they were looking. They were concerned, they were looking to go organic from conventional dairy. They were concerned about what are we going to do about all the medicines we use on our cows, because we give these different things for these different problems, and how are we going to take care of that when we're organic? And really, over time, it dawned that it's better to prevent problems than to treat them. And so rather than learn about tinctures and natural remedies and herbs and all that, why don't we work on prevention? And really, after working with organic farmers for a while, these three things really stand out that really makes a difference, because a lot of conventional cattle operations feed grain to get increased production, increase growth, increase milk production, increase beef production. Grain is fed for that reason, but cattle, being ruminants, are really meant to eat a high forage diet. They can eat some grain, but they're meant to eat a high forage diet. The grazing itself, besides having impact on the land, has impact on the cattle. The exercise, the fresh air, the green feed, all those things are good. And then the soil. And I used to have this say mineralization and biology, because I thought about the minerals first, but I just switched this around for this talk and put biology and put it in bigger letters, because it's really about the biology. And those three are not in an order of 1, 2, 3. It was like the triangle for disease. These three work together. And so you need to have all three of these things working together. And those are the important things that really make an organic system work. And that would be for all ruminants. I said dairies, but it would be for beef cattle, be for sheep and goats too. So let's talk about soil a little bit. And people tend to think of soil as dirt, place for plant roots. We think about the physical aspects. So we dig up a spadeful of soil. We think about that, we call that soil. What goes through your head when you hear the word soil? What do you think? You probably see a shovelful of dirt. But in each of that shovelfuls, each handful, each cupful, there's a lot of life going on. And that's what I really want to talk a little bit about, the life in the soil. Because we talk about the mineral balance, we talk about that. And people even talk about how important the life is, but we really don't talk about that life itself so much. And it, again, is a very diverse, complicated but beautiful system. And how many of you are familiar with Dr. Elaine Ingham's Soil Food Web? That's been around for a while. You've heard of it, yeah. And basically it's that the organisms are like levels. The plants, of course, fuel everything, because sunshine feeds the plants. And John talked about the fact that making that sugar, that's what starts the whole system. And then the sugar feeds down into the roots. And so I think that's a really important thing, is the root exudate. And what we never really thought about so much is how much the plants are actually feeding the microorganisms. So this is our bacteria. This is a protozoan. So this is the next level up. These are all like insects and mites. and there's a lot of different kinds of worms, microscopic nematodes, and then even earthworms. And so what you don't get a feel for in this thing is the actual sizes of these things. So the bacteria are the tiniest, they're really small. And these protozoa are much bigger, and they actually eat those bacteria. So they're like the predator for that. And then these guys are much bigger than this, and they would eat this. And so there's a lot of different things eating each other, for one thing, but they also are in this system. And I don't pretend to understand it all. And I think most people don't really understand it all. But the important thing is to realize it's there and that we don't want to hurt what's happening. You know, we don't want to do things that are going to make things die. So here's just another one, and this is a picture of a roundworm. Anybody have seen this picture? Do you know what these are? With that rope and collar, what that is? That's a fungus. It's called, and it's a fungus that actually kills the worm. And the point of this slide is that there's checks and balances. So if you have a complex system, nothing really gets so far out of balance because things are going to control each other. And so that's a nematode trapping fungi is what they call that. And so nematodes are roundworms. And you know, you've probably heard of nematodes that affect roots of plants and things like that. But there's balance there. And then there's all these bugs working together. And again, it starts with the plants making these exudates. And it's not just about the residue, the plant litter that's breaking down. It's not about that to make the organic matter. It's really the more important things that the plants, and just what John was saying, is you maximize photosynthesis, maximize output by those plants, they're going to be putting more into the ground. When the plant is suffering, it's not going to let go of its nutrients. It's not going to be feeding that life. And so when the plant flourishes, everything flourishes, okay? And so I think that's a really important thing, that carbon flow into the system. All right, this might be a little hard to see in the back, but basically it's a prairie plant picture with different root structures. And so the roots go down to quite deep depths, and we'll come back to this slide later. But I wanted to make the point here that these systems are complicated, but the thing is they all have all these different, the diversity brings a lot of different things to the party. So you have plants that reach down to different levels that can dissolve different minerals, they absorb different minerals, and we know from analyzing the plants that some of these plants have higher levels of, let's say, sulfur, which John talked about sulfur being important for plants. Well, it's also important for animals because it's important for making protein in animals too. So higher sulfur containing plants are very helpful. Mycorrhizal fungi, everybody familiar with those? So when you look at a picture like this, it's just a little bit of the true picture because we don't see the mycorrhizal fungi. And this is just the roots of the plants. So mycorrhizal fungi, you know, they go out from the roots and expand the root mass and they get a lot bigger. And so there's overlap between these plants. These plants are connected. And we know, like in the case of trees, that trees actually transfer nutrients from one individual to another. We can put a radioactive sugar in one big tree and actually find it in a small tree. So in a forest where there's a canopy that totally covers everything over, a big nurse tree can be feeding small trees through the root systems. They're connected through that mycorrhizal fungi. And we're finding these connections and the mycorrhizal fungi are pretty common between a lot of different plants. And so things are connected, things are moving. That's the other thing, you don't get the snapshot again. You just don't get all this interaction. And remember, all these pictures with all these bugs and all that stuff, that's all in there too. So it's all going on at the same time. All right, let's talk about parasites. So in this case, we're going to talk particularly about the worms from grazing that cause problems in grazing livestock. And their place where most of them live is in the intestine and in the stomach. And what they do is they lay eggs there, and the eggs come out in the manure, and the manure falls in the pasture, and then those eggs mature, they hatch, and then the larvae come out. And the larvae have to go through some stages. They have to live in the pasture for a while before the animals can eat them and become infected. And so the way the worms work is they lay these eggs on the pasture. Those larvae grow and mature, and then they would crawl up on blades of grass. And so this is a blade of grass with a dewdrop, and if you see little white hairs in there, those are the baby worms. Those are the larvae. And so when a grazing animal eats that plant, that's how it gets the worms. Those larvae, those babies, they can't take heat or dryness. And so the importance of that is that when the sun comes out and the dew dries up, they have to get close to the ground because they will just dry up, they'll shrivel up and dry. Have you ever seen like when earthworms crawl on the concrete and they get too far away and then they never make it back and they dry out? Well, that's what was happening on the plant with these guys. So the importance of that is if we don't want to graze too short. And so parasite control is really not about the dewormer. It's not, we focus so much about the dewormer. And going back to this slide, people think about the worms in the animal, that they're in the stomach, and what can we give the animal to get the worm out? But the worm's life cycle is such that it really spends a lot of time outside the animal. So the biology that's going on out here is going to have a lot of effect on how the parasite pressure is. It's not just about what's in the animals. It's also about how we manage that environment out there and what kind of competition those worms have in the environment. So this is the typical problem we see. And again, here is a dewdrop, and you can see the little worms there. And in dairies across the United States, a lot of people, when they wean their calves and they have to start grazing them, they put them in a paddock, an area that is just a set area. So it's set stock. And those young ones are there. They've just been weaned and they stay there. So what happens? What happens to the grass in that place? Anybody? What happens to the grass? It gets short. It gets real short. And so if there's any worms there, the calves are going to pick them up, because remember that worm, it'll come up on the grass in the morning when it's cool, when it's wet, and when it starts to dry, it goes down to the base. And so leaving that short grass like that, they're going to get the major amount of worms. Now, if you don't rotate this, and what I see some people do is they have this same area all the time, what happens to the worm population? It goes up. So it gets to be more and more of a problem over time. So sometimes just moving this area to a different area will be somewhat helpful, but really you have to change the way you do this. And what you really want is you don't want to eat the grass down so far. You want to move these calves. So there's different ways to do that. And there's different, I'm not telling you how to do it, but basically the important thing is that you leave 4 to 6 inches of residue of grass. And I'm not talking just the weeds they don't like to eat. I'm talking the stuff they like to eat. You leave some residue there and you rotate those calves. Yes, Irvin?
Did the worms go by season?
Do they go by season?
Yeah.
Yes. Yes.
Like, they're not there in the winter.
They can be. So the worms will be less in the winter, and it depends how cold the winters are. So up by us, a lot of the worms get killed off, when it gets after freezing temperatures. And so the population is lower. Some of the worms have eggs that are tough enough that they can overwinter, even in the harsh environment. So here in Kentucky, I would imagine the worms probably last through the winter pretty easy. There's less of them in the spring, but as the summer progresses, there gets to be more and more. So if you're somebody that has calves that, throughout the summer, you're going to have more parasite pressure towards fall because the population is going to go up. Now, the one thing about that may be a little bit different down here and further south is if you have a real hot, dry spell, that'll take the population down. Because remember, they don't like drying out. And so you can actually have a decrease in July and August and then have it come back up when it gets cool again. Up by us where we have, it doesn't generally get that hot. The worms just kind of gradually go up the whole season in the upper Midwest or in New England or whatever. But in the South, it definitely goes up for a while, and it gets hot and dry, it goes down, and then it comes back up again.
It seems our spike is in the fall anyhow.
In the fall, yeah.
And I was just wondering, those paddocks, if it got really bad, could you overseed it with like a mustard or anything like that? Is there any bioremediation of these worms?
Yeah, it's a good question. Yeah, well, that nematode trapping fungi. Actually, one of our farmers did he went to grad school and he did a project with that fungi, and they actually saw reductions in worms. So we had never done the experiment, but one of the thoughts is you could use for bioremediation is you could put this maybe spores of this fungi out there and get more of those. And there has actually been some research with that. It's hard to manage, so. Basically rotation, taking a place where cattle haven't been before, hayfield, turning it into, letting it rest. That's probably the best. I mean, yeah.
But you didn't see anything with like a mustard, any brassicas like growing with the glucose?
I don't. Is there a known effect with brassicas or?
I mean, we just see it with some plant diseases, but I didn't know.
Yep. And I'll get to the tannins and stuff with the chicory and that stuff. That definitely makes a difference.
Okay.
Yeah, but that's more. Not so much killing the worms directly as actually when the animal eats it, it's actually like a dewormer, a natural dewormer for the animal. So we'll get to that. But the idea here is just to move, and how you do it, it doesn't matter. Some people would take hutches and on the pasture and move them. This is that net wire fencing and basically a small area. Once they get down to that 4 inches or so, set up a new area and move them. This was just a movable pen, and I like this movable pen concept. It wouldn't really work on your farm, Irvin, because of all the hills. But this is a nice concept that this is one of my favorites, and this is one of our farmers who's pretty handy, and he built this 20 by 20 pen. He's good with welding and he's using hog panels, and he raises about 10 calves in a pen. And they're a spring seasonal grass-fed herd, and they calve with a lot of calves, so they can do this. They can make groups like that. And you can put a shade. You put a shade on there, of course, when they're out in the sun. You have water, and they feed milk for at least 3 months, sometimes to 4 months. Full milk feeding for 2 months, and then backing off that. And the milk itself is antiparasitic, so milk suppresses both coccidia and worms, and so. That's one of the things about organic is I'm not going to talk too much about coccidia, but I'll just mention it because coccidia happens from after a first month of age up. It really hits at weaning time because we take the milk away, and the milk is anti-parasitic. It suppresses the coccidia. You take that milk away, and then the calf is more susceptible. In the conventional world, when they feed calves grain, they'll put a coccidiostat in it, and that will get rid of the coccidia. We don't use coccidiostats in organic. So part of the reason that we give milk for a longer period of time is to suppress the parasites. And you guys that raise beef cow calf, there's really not much of an issue when the calf is on its mother. There's enough suppression from that milk, it helps a lot. And the nutrition is really good for the animal too, so their immune system's stronger. And it's not a matter of limiting worms totally. It's getting the animal to grow into it gradually so that the exposure is less and they get an immunity to it. This is the same farm, and now there's these different age calves, and they just hook on. And so when the calves are small, they'll move them each feeding. So twice a day they'll move them just the distance of the pen. And then when the calves get a little bigger, they'll move them both morning and night. So instead of once a day, I guess maybe I said it backwards, but they do start out once a day with little calves and go to twice a day afterwards. But it's really easy to hook on with a four-wheeler or whatever and just pull them forward. And another important point is that there's a lot of, it's not just about getting them out there, it's what are they eating? And so here we see a nice diverse pasture mix. So diverse pasture mix, there's grasses, there's legumes, and there's forbs. And the forbs are the things that really bring some antiparasitic, even dandelions have some of these tannins in them, the dandelion leaves, but especially the chicory and the plantain. And I really like the narrow leaf plantain. That's a plant that really it's also very nutritious. It's got a lot of minerals in it. So these guys raise their calves on milk spiked with kefir, and kefir is a probiotic like yogurt. How many of you guys, anybody do kefir at home? Yeah. Do kefir for your calves at all? No. Oh, just you? Yeah, me too. Yeah, Yeah, it's really good for you. And then we'll talk about microbiomes, and that's what that's about. But this is a really good system, and they raise beautiful calves, and there's no dewormer involved. They're organic. There's no grain to these calves. They grow them well, and so that's the way it goes. So in summary, then, the grazing management is really important. Leave that 4 inches or more. One Band-Aid or kind of helpful trick is to supplement them with some diatomaceous earth. So DE is not a real good dewormer. Once they're loaded with worms, it doesn't really get rid of them. But if you use it as a preventative, and we like to see it mixed in a 1/3 salt, 1/3 kelp, 1/3 DE, like 1 coffee can each or 1 bucket of each. Mix that 1/3, 1/3, and offer that as mineral for those heifers in their first growing season. And that's very helpful, is that 1/3 salt, 1/3 DE, 1/3 kelp. And kelp has got the iodine, it's got a lot of good things in it. And that's by volume, because DE is very fluffy. A 50-pound bag is really big compared to a 50-pound bag of salt. So we go by volume. Yeah. Any questions on that? So parasites in summary, the milk is important. The grazing management is the most important. That's why it's in bold. That how you manage that grazing, that first grazing season in particular. When they come back the next year, they got a little more strength to them, so they can take a little more exposure. Don't hurt the dung beetles. So we talked about the fact that the worms are living outside of the host, and the more active the biology is, the manure recycling is really important. How fast those cow pats go away. So you should really watch your cow patties in the pasture, how fast they disappear. And really in a healthy system, when it's not real cold or there's enough moisture, 10 to 14 days, your manure pat should be pretty much gone. If you're seeing manure pats that are sitting around for months, either it's frozen or it's dry, or you don't have good biology. So you can use that kind of as a gauge. There are herbal things with garlic or black walnuts. Those things are out there. We really don't emphasize that, other than allowing them to graze some of the plants that we know are antiparasitic. We talked about some of the forbs, but also the brushy plants, the woody plants, have tannins in them. So if you have hedgerows that they graze some of the softer plants, that would be very helpful too. The other thing is genetic selection. So if you raise 20 calves and you have 18 or 19 that do just fine and 1 or 2 that are wormy, maybe they just don't fit your system. Maybe there's something about their conformation, their constitution, their immune system, that they're not fit for the system. So maybe those ones and the other thing is, an organic, you can use an emergency. You can use a dewormer, a conventional dewormer, but that disqualifies the animal for beef purposes. You can still milk that animal, but it disqualifies them for beef. But maybe you want to get rid of the calf that just didn't, the rest of them did just fine with your system. Any questions on parasites? Let's go to flies. So this is if anybody's interested in learning more, this is a good resource. It's Cornell's Integrated Pest Management. If you just go to their website and search for organic fly control, you'll come up with this one. Originally this was 2010 and they updated it in 2016. I don't think it's been changed since then. But if you really want to learn, flies are a little bit complex because there's a lot of different kinds of flies and they have different ways of growing and living, and so the control is different with them. And so if you really want the encyclopedia, that's there. But let's just go through it quickly. Flies, a lot of them breed in the wet organic matter. So keeping things clean is really important for flies. For like the house flies and the stable flies, the filth flies they call them. If you keep the manure, and not just manure, but keep the wet feed cleaned out. Keep things so the flies can't breed in that. That's important. This is in Wisconsin, and this guy raised calves on straw bedding all winter. And in the spring, when it got warm, he would get a load of sand and put it in his hutches. And we're not raising calves so much in individual hutches and organic anymore. We're actually grouping them, or at least pairing them between 2 hutches. But the main point here is to get rid of that organic matter that breeds the flies. Because you probably notice if you go out and feed the calves, sometimes there's a lot of flies around, or a lot of house flies and things like that. And so getting rid of that organic matter where the flies breed is important. Out west, they actually use wood chips that have a lot of essential oils in them, and that really suppresses the flies too. So fly traps, sticky tapes, there's the ones on the reels, the long ribbons, those work quite well. You guys are you familiar with stable flies? The ones that bite them on the leg, and they're always lifting their leg and things like that. Do you have those? Yeah. And they bite you too, right? Yeah. And so the stable flies, there's something called a stable fly trap. The Star Bar makes them, and this plastic has this is a close-up of it, and that puts out a light that's attractive to stable flies. And I don't know, you probably can't see it, but there's actually like a little point sticking out of this guy's head that shows it's a stable fly. They actually have a little knife in their head, and what they do is they saw through the skin and then they lap up the blood. And a horsefly does the same thing on a bigger scale. But these stable flies, once this traps, you can hang them around where you got calves or you got, once a few flies get on there, they see the other flies and they come and they get coated. They really catches a lot of flies, and it works quite well. We use it around tables and stuff on the deck at the cabin, and it really we have a lot of stable flies there, and they bite the people a lot. And if you put these traps out, you really keep the population down. It helps. I put this slide in for horseflies because the farm we were at yesterday said they had a problem with horseflies, and horseflies breed in little streams, clear water, and so you really can't eliminate their breeding areas. And how many of you guys have horseflies? Okay, and this farm said that they had them for 6 weeks, and the thing about it is they are strong flyers. They'll fly over a mile, and so they'll come from a long ways. They're good, big size flies, and they mostly attack during the hot heat of the day. This is called the horse pal, and it's a black ball, but it's like the belly of a horse, and the horse flies will land on that, and then pretty soon realize it's just plastic, it's not a horse, and a lot of them fly up into this area, it necks down, and there's a jar up here. And so they go through this little opening up in here, they get stuck in there, and then they just get roasted in the sun, so it kills the horse flies. And it's actually pretty effective. People with backyard horses that have horsefly issues that put out even just one of these things makes a big difference. And so, is Nathan here today at all? Yeah, there's you. Okay, I thought so. Okay. Yeah, this is what we were talking about yesterday. And so, even if a guy had one of these, you could probably make some more. The interesting thing about the horsefly is I asked Irvin today about, because Irvin has a couple of streams coming through his property. He has ideal horsefly habitat, and he doesn't have a big problem with horseflies. So something about the biology at Irvin's is different than the biology at your farm. And so, it might be a thing where just sometime go spend some time over there and just take a look at that farm, the way they do things, because there maybe something will stick out. But it just, there's a difference in the biology. So it's not always about the solution. That this Epps trap is another one. They just fly into this, and it's actually got a piece of plastic that you can't see so much in this picture that they bounce off of, and then these are water troughs, and then the flies. We have deer flies up ways. I don't know if do you have deer flies here? You do? Okay, yeah. So those bigger biting flies, that's what these are for. This is a walk-through trap called the Bruce trap, University of Missouri. And it's been around since the 1930s, and you can make these, and horn flies are really one of the biggest issues. Horn flies is a little fly that's on the back, on the shoulders, on the belly. You see them sometimes, and they suck blood, and they're really a nuisance. And I imagine you have a lot of those horn flies, and so walking the cattle through this will help some. And a little detail on, basically it's two screen layers. The sides are two screen layers, and they're pleated. So this is a close-up on the inside from looking inside out, and you can see they're folded so that, and then there's little holes, and basically the flies come off the animal, they go towards the light, they find the hole, and they get in between the screens, and they're kind of trapped. It's like a minnow trap. And so that's just an old, easy system. It's not as effective as the newer way, which is the fly vac. Is anybody here, have you ever seen a fly vacuum, or anybody have one? Nobody has. For horn flies, this is really a good solution because if your cows come back to get milked and they walk through this twice a day, it really makes a difference. It takes the horn. And we have farmers that have built these homemade models of this with just using exhaust fans and building a box around it and that sort of thing. This one is better because it actually has fans that blow the flies off and then vacuum that suck them up. And really what's important when you make one is that you have a good seal with some brushes or maybe some pieces of some flaps so that the horn flies don't just all flare off of the animal. And we have a farmer that built one of these. These are like $8,000 now to buy one of these, and this guy built it for like $400 worth of material, you know. So, but that is a really good solution for horn flies. It works pretty well. Biologic control. Anybody use the predators, the wasp predators? Yep. Yep. And so they're basically a tiny little wasp. This little pupa is really small. It's only like a 1/4 inch long. And so these guys actually lay their egg in there, and their larva, their baby, eats the fly larva and kills it. And so the thing about these is it's a numbers thing. You got to get at them early before the fly population goes up because there aren't enough parasites to. If you got a big explosion of flies and you try to knock them down with this, it's not going to work. And they work more in like around the buildings and stuff where the flies aren't so spread out. There's also beetles that parasitize the fly larva, and then these are some sort of mite. So there's always these natural checks and balances, but birds are something that's really important. And the purple martins are starting to come back. You guys, the Zimmermans, you have them now, and Irvin, you said you're not, yeah, but you said they come about a week later at your place. So anybody else have purple martins? Yeah, are they here? Yeah. You guys got them? All right, great. Yeah, they're super. There's a lot of different swallows too. These are some of the common swallows. The tree swallow likes the nest boxes. So if you make the boxes, I'd say the barn swallows, they're on the beams and stuff in the barn, and then the cliff swallows, they like to go under the overhangs and build the mud nest, the jugs. And this was one of our farmers out west where he actually took and built some of the jugs he just took pieces of wood and then he put chicken wire on it, and then they put modeling clay on top of it and made these jugs like this. And the actual wild birds came in, and the ones they made were like this. They didn't have the opening. And you could tell when the birds were in there because they built the opening, they built the neck on there, and they actually they built one built one in between the other ones. So encouraging the swallows, encouraging the martins, that's a really important thing. They're really good for fly control. And this is that same farm, and they got a lot of tree swallow nests, and they got a whole lineup of them close. That's a tree swallow there. And it's really interesting because they have a garden out there, and they have picnic tables, and you can sit out in their summer, and you don't get bothered by flies at all. It's really nice. I don't have the videos here, but Kevin Yankee, who's one of our farmers, he has some videos that he made of how to, this is just taking old socks and making what he calls bullets, where you can soak them with some essential oil products, and it's a mineral feeder, so when they stick their head in, they get some of the stuff on them, and the face flies are off. But he also's got oiler and shows how to use gates and just make an oiler with PVC pipe and pieces of rope. But if anybody's a member, we'll be happy to find a way to get you if you want to see those videos. But Kevin's an interesting guy, and one of the things he came up when we talked about flies is he talked about he had taken those traps that they had, those little stinky traps for flies. He scaled that up to like the size of a barrel. So he's always trying new things. And so he had this fly barrel, and I didn't even put it in here, but another interesting strategy that he found is that this is the barn here, and this is where the milking parlor is, and these are the laneways going out to the pastures. And so it's a very hilly farm. This is the top, and it goes down, and this is like along a little creek here. So this is the lower part. And there's woods throughout the whole thing. And he just noticed when he was on the trail with the cows one day, the fence was down, and it was during the height of fly season. Well, first off, before that, he notes that when he goes out to get the cows, there's a lot of flies around, and a lot of the flies get off of the cows and get on the fence posts or get on the trees that are close by and just stay there. And if he brings the cows back to that area, the flies just come back onto the cows real quick. And he's just always watching this stuff. And so he figured out that, you know, instead of, when we're grazing, we often like to just go from one paddock to the next paddock to the next paddock. Well, he'll hopscotch. He'll put cows here and then he'll put them down here. Or he'll move them around just because the fly pressure will be less when the flies are bad. The other thing he found out was he was moving the cows and there was a fence down and the cows were going down somewhere down here, and instead of taking the road, they took the shortcut because the fence was down. And what he noted is that because of the leaves and the brush and everything, the flies all got brushed off the cattle. And then the flies were in the woods and they got in the trees and everything. And he said that I think the flies got disoriented and they couldn't find the cattle back, because when the cattle came out the end, they were all clear of flies. And so now he says when the fly pressure is bad, I make a practice of running them through the woods on the way to the pasture. So I don't know if that would work, you know, depending on your underbrusher or stuff, but it was an interesting strategy.
He's not going to let the fence down every time.
No, but he'd actually force them in. He'd actually make the fence so they'd have to go through the woods.
Okay.
Yeah, with polywire, yep. So this is Kevin's philosophy. I kind of like this. Nature's in charge, we're along for the ride, but we can steer, you know. And I think that it's a good point, is that if we align our production with nature rather than fighting it, things are a lot easier. You can think about that barge going down the river. It's burning a lot less fuel than when it's going up the river. So working with nature is really important. And I think this whole thing about is interesting. Everybody has models in their head about how things work, but he said, you know, grass-based farm is a solar panel and the forage and soil are the battery. So the more life we can put in that soil, into that grass, the more we're going to put into our cattle and our system. And so it's just really good farmer common sense. I really like it. And the other thing he's saying is protect the soil. You know, the soil is top 6 inches. You know, every other living thing on your farm needs food, water, and shelter. Well, what about the soil? You know, don't leave the soil bare in the heat. Keep it sheltered. Yeah. All right, so we're going to finish up with some talk about diversity and how it ties back to health and resistance and all of that. And so why is it important to have diversity in a perennial pasture? And so that's another thing, is perennial versus annual. And so pastures being perennial, those root systems are going to develop deeper, more interactions, more connections over time. So we really want to minimize the amount of land that we're turning over. And really, a lot of times interseeding, adding seed to stands that you have, drilling some seed in, is better than tearing it all up and starting over, because we're tearing up all that structure, all that, we're disturbing all that biology. Okay, so the perennial system is one that can build a lot of soil carbon. We'll talk about that a little more. But I think to John's point, you know, John Kempf, is let's get those plants making as much sugar as we can, putting as much exudates out of their roots to make that soil alive, because that's going to actually build carbon over time. That's important. Yeah. So some of the reasons, and so what do we mean by diversity? Again, the grass, the legumes, the forbs. And why the legumes with the grass? That's a basic one. Nitrogen, right? Yeah. Nitrogen. Our air has a lot of nitrogen. The legumes can fix it. The grasses need it. So that relationship is.
More relationship to it than just that.
Yeah. What do you mean?
Well, they just eat everything better when they're together.
Yeah. So the more diverse, they eat everything better. And so one of the things we see too is that the harvest window gets wider. So even if it's just a hayfield, if it's a hayfield that has a lot of diversity into it, you know, alfalfa, it's supposed to be cut at the 1/10 bloom stage. If you go 2-3 days beyond that, your quality is dropping. If you have one of these mixtures that have grasses and legumes and forbs in it, if you get a rainy spell and you miss it by a week, 10 days, it doesn't make that much difference. It's amazing because different plants come on, they're maturing at different times. And so we've seen a real widening of the harvest window where you can still get quality feed by having a diverse forage. That's one thing we see. Then there's plants that are medicinal. In Europe, they actually call this an herbal ley. So that's a paddock that would actually have more of these plants, and some dairies have actually carried to the extreme where they would have a paddock just dedicated to mostly medicinal plants, and if they had a sick cow, they would put it in there and let it eat what it wants. There was others that talked about how they had some of these plants mixed into certain paddocks, and then the cows would go through that paddock once a month, and it really made a difference in their health. And so we shouldn't underestimate the cow's ability to pick out some of these things if we know what they need. Yeah.
Can you give some examples of the medicinal plants?
Say it again.
Can you give some of the examples of what the medicinal plants?
Yeah, so there's the one in here called Little Burnett, that's what this is. What we talked about before, the plantain, the narrow-leaf plantain is a good one. Some of the medics, which kind of look like a little bit like a small alfalfa plant. There's a whole bunch of them out there, and so if you just look it up, and actually there's a company that actually makes a herbal mixture it's called Prairie Creek Seed, and they make an herbal mixture. And this is actually their one of their plots. But again, it's going to help that soil biology, the plant health, and the interesting thing about, Irvin, you said about they like it better. One of the things we've seen on the same farm is if there's more diversity in a field and a pasture, there's less like rust in the fall. There's in the grass plants. So something about that relationship is making that grass plant stronger to resist the fungal infection, and that's going to affect palatability right there. So, it all makes sense that animal nutrition is better, more minerals, the protein, the energy amount, and then those secondary metabolites, the PSM, John called them, plant secondary metabolites. They're really important. Those are actually the things like the essential oils are what make the plant medicinal and have its effect. And this ultimately affects us because when we eat these, when we talk about grass-fed milk, grass-fed beef, we focus on the fats. We talk about omega-3s, we talk about CLAs, which are really important, but we're not talking about the antioxidants. We're not talking about the plant secondary metabolites. There's a lot of stuff that we don't know about yet. And we know that grass, this is again, the difference between scientific theories and proofs and just really being observant and taking it in. And just, when you look when you go out and see cattle eating a lush, diverse pasture, you just know it's healthy. And when you drink the milk from those cows, you can taste it. So back to this picture. And the thing about perennial plants is they can make roots over time that go very deep, that are very massive. This is an annual grain growing. This is in Kansas at a station. This is a man, that's over 6 feet tall. And you can see this root is over 8 feet deep. The root structure on these annual wheat plants is very tiny, very small. So you're not putting much carbon into the soil. You're not feeding the bugs. You're not, invigorating the system. That's where the beauty of these perennial systems is. So there's more interactions, the more carbon flow going down there, more carbon sequestration, and there's all this talk about climate change. And so we're going to shift a little bit to climate change because I'm sure, we know, I saw some of the tornado damage driving down. I know you guys had a terrible thing happen here with the tornadoes, and it was pretty impressive, the stretch along the freeway that I saw, the way those trees were twisted and stuff. It was amazing. So what that does is changes the environment for some of the insects and the pests and stuff. And so we're seeing more tick-related diseases in both people and animals. And in animals, there's one called anaplasmosis. You have anaplasmosis? Anybody had that in their cattle? Okay, a few, yeah. It's a blood parasite. It's borne by ticks. It's a blood parasite. When I went to vet school in Wisconsin, and when we talked about parasites, they said anaplasma was something you saw in Alabama and Georgia and the Southeast. And in the last few years, I've gotten calls from Iowa with anaplasma. And we got it in southern Wisconsin now. And so things are moving north. And so there's this related disease called babesiosis. It's another blood tick. It's a blood parasite. It's not so much here. It's in tropical areas, mostly in Africa and South America, but it's all the way up to the Mexican border. So they're watching for these ticks, these carry that. Some of you heard of this? Have you heard of this Asian long-horned tick. Have you heard of that at all? No. Okay. Some of you heard of it. Okay. Yeah. So this came into Virginia, and it really affected some beef cows. And there's a bug called filaria, which is a lot like this anaplas. It's a blood parasite, and there's a specific kind, this orientalis icada type, and this was documented in Virginia. It came from New Zealand. So New Zealand and Australia, they have this tick, they have this parasite. There was some sheep brought into Virginia, some hair sheep that brought this in, and now this tick is multiplying, and it's interesting because it's all females, and the females can just keep splitting and making new babies without ever having a male. And so they multiply really fast. This is an ear of a sheep. I believe it's New York, it's either New York or Pennsylvania, and you can see some of the bigger ticks, and there's a lot of little tiny ticks there. That's this guy right here. And this is the yellow is where it spread. It started in this area here. It's spreading up to the north. It's spreading here. It's been in Kentucky. It's been in 5 of 120 counties reported as of the end of last year. Yes, good. So the interesting thing about that is, if you're conventional, you use oxytetracycline for all these blood parasites. Organic, you can't do that. And so when we have an organic animal, and we had one of our farms in Virginia that got this problem, and they actually did testing, and they found out that it was this particular parasite. And so all we can really do is support them, or we could make them conventional if we wanted to give them antibiotics. But we would give them garlic and different things, but we give them vitamin B12 and iron to build their blood up because they lose a lot of their blood from the parasite. And what interesting thing is what Phil reported is that he's had it in his herd for 2 years. The first year it hit pretty hard. So with a population of cattle that had never seen this before, it was hard on the animals, and he had more sick animals, and he had like 4 or 5 that died out of 100, 150, something like that. Next year, no more deaths. He had a couple that he had to treat. And so his herd is getting resistance to this. So these new things come in and they can do some damage. But if we have good resilient systems, they take care of it. The resistance builds up over time. It doesn't keep us from having a big loss when something new comes in. So that's why it's good to have some protection with vaccines and stuff in some cases. So this also affects people, this climate change and these parasites. And so have you guys heard of Lyme disease? Oh yeah. Anybody had it? Yeah, I've had it a couple times. And this is the classic bullseye pattern. I never had that, but you can see it's spreading north. It's spreading. A lot of these different diseases are spreading. But the thing is, these ticks and stuff that would normally be in some places are spreading more. But the interesting thing about Lyme disease is it's this deer tick, this black-legged tick. And so here's the tick that causes it, this black-legged deer tick. And this is one of them on a fingernail. And I would say this is a really big one because generally the ones I see are like half that size or smaller. They're very tiny. And the interesting thing, when they dig in deep. This one's not digging in real deep. They'll dig in deep, so deep sometimes where all you see is a couple of the legs sticking out. And they don't, like the wood tick, the dog tick, that one will engorge with blood and get like a grape. Have you ever seen those ticks where they get big? This one doesn't do that. And so if you don't watch close, you could have it, bite you and come on and go off and never know it. And so that's why some people break out with Lyme disease. They don't even know they had the tick. But the point here is that these ticks live a lot of times, like these wood ticks and these deer ticks live in tall grass. And so in northern Wisconsin, where I'm used to walking around in grass and stuff, if I go along the roadside, and even this is one of our grazing, this is actually the same farm with the calves. If I go down along the road and just walk in the tall grass in the early spring, I will have a lot of ticks on me. I'll have, if I have my coveralls on and my boots are closed, they'll just be coming up. I mean, I could 20, 30 ticks at once. And when I walk through these farms, and these 2 farms, I walked them all summer long on a 10-day interval for checking their pastures, I never had one tick in there. And so what's the difference? I don't know, but I think it's yeah.
But I can walk through the woods or through the grass, tall grass or whatever, wherever the cows has been grazing, I probably won't get a tick.
That's been my experience. So did everybody hear that?
Go into the woods where the cows haven't been.
They'll get a tick. So have you heard, did everybody hear that? where the cows have been, and that's what we see it all the time too. And why is that? Who knows? I mean, but this is the point too, is
The cows get some, but not.
yeah, but there's something about the biology that's different.
Yeah.
And so do we really have to know exactly? It's nice when the science tells us what it is, but do we really have to know? Yeah.
I heard somebody say already sulfur makes a big difference.
What makes a big difference?
Sulfur.
Sulfur. Glad you brought that up. So sulfur makes a big difference, and that really could make a difference. It's one thing I didn't talk about on the fly control is the products with the garlic salt. Anybody use that on their animals? Yeah. So what garlic, when you smell garlic, clove, or you eat something you got on your breath, do you know what those compounds, what they contain? Sulfur. Those are sulfur-containing compounds. So feeding animals more sulfur will make them more resistant. Sulfur is not very palatable. So there's this garlic salt, or there's a mineral that agrodynamics has called flies-be-gone. It's high in sulfur. It raises sulfur compounds in the animal, probably makes them less attractive to both flies and ticks. So sulfur is important.
So does the severity of a winter have any effect on ticks or any of this stuff?
Severity of winters, yeah, it certainly does. They certainly go. You don't see them once it gets once it starts to freeze. You don't see them by us. You can, if it warms up a little, you'll see those deer ticks will come out in pretty cold weather. But then in the spring is when they come on, and then when it gets dry and hot, they go away too. So that's another thing. But there's differences, and this is a bobolink. I don't know if they travel through. They don't really nest here, but they nest up by us, and they're a grassland bird, so they need a place that's undisturbed. Yep. So it's just an interesting observation that the ticks are not there. So microbiomes, okay, and this is kind of on purpose that this slide is so busy. And microbes is just small life. So this microbiome, and everybody's talking about microbiomes now. And there's microbiomes, in the gut. There's microbiomes in the rumen. There's in the soil, in the plants. Let's just go with the rumen here. Does anybody know what that number is? So you got in your head what 1,000 is, right? You can kind of see what 1,000 of something looks like. So 1,000 thousands is what? It's 1,000,000. 1,000 millions is what? It's 1,000,000,000. What's 1,000 billions? A trillion. What's 1,000 trillions? A quadrillion. That's what that number is. It's a quadrillion. Okay? So there's a quadrillion bugs per cow, because in each 1 cc or 1 milliliter, there's 100 billion bacteria. There's 10 times, more than 10 times the amount of people on Earth in 1 milliliter. Okay? An ounce is 30 of those milliliters. So there's a lot of bugs in there. A lot of different bugs. And what we're finding out is that there's just all this, over 90% of them we can't culture. So science really hasn't known about a lot of them until the last few years, where they've got these new techniques where they can look at the DNA of these bugs and they can say what's in there, but it really just says nothing about how they interact. It says nothing about if they were alive or dead when they tested. There's just so much unknown. So the point is that it's a lot of complexity. It's really interesting when it's brought, there's a lot happening with human health now and these biomes. And the fact that, John talked about the autoimmune diseases, that they doubled autoimmune diseases. Well, a lot of this is the fact that we are just so clean about things that our microbiome isn't healthy anymore. And so it's really the microbiome that determines the health of the plant, the animal, the person. And so I think we got to think about those things. I'm not saying we have to be dirty, but we got to not be so sterile and worried about all that stuff. So in the case of plants, we had that really interesting talk today about how these microbes are taken in directly by the growing root. How many of you heard of that before? One person, yeah. Were most of you here for John's talk this morning when he talked about that? How the bacteria actually enter the root. They get stripped of their cell wall. They cycle through, and the bacteria spits them out and gives them everything they need to build a new cell wall. And so The bacteria that are inside the plant would be endophytes, because endo means inside, yes. And so endophytic bacteria are inside. So those bacteria were actually endophytes for a while, and then they're in the soil microbiome. One of my point is that these classifications are artificial. There's interaction, there's crossover. Where does the soil microbiome end and the rhizosphere microbiome? Where's the point? There's bacteria that are overlapping, they're going back and forth. And so conceptually, we make these models in our head, but that's not really the way it works. It's all connected, okay? And this one here is a bit busy too, but the main point here is that people over time, the way we live has changed, in the last 1,000, 2,000 years, where we were in contact with the environment, we were in contact with the soil. Actually, we were in contact with feces more. And all these things allowed bacteria, microbiomes to interact with each other. And in modern life, we have so much sanitation, we certainly don't get in contact with feces, and I'm not saying we should, but the thing is we have, normally the soil microbiome would be going to the plants, but we talked about hydroponics, that there's no soil there. Pesticides, there's a lot of things that we put in the soil that kill the microbiome. So all these places we're breaking the cycle. And what that does is it shows up as health problems. A variety of health problems are being linked to these. And so my point is not that we have to keep track of all this, but if you go and if you just watch it, there's stories coming out every week about a connection between a different human health problem and what's going on with the gut bacteria. And so the point is that let's not hurt things. And one of the things that's really important, he talked about nutrition. And so not only the hygienic measures of antibiotics, of course, are killing bacteria, but a low fiber diet of processed food, that doesn't feed the microbes. That's why we need to eat those vegetables and fruits. We really need that for health. And it's not so much for us directly, it's for feeding those bugs that take care of us. Because our immune response depends on the health of that system. The people that are dying from COVID really have a difference in their immune system. Their immune system gets too reactive. And they're finding now that there's a link between how reactive that immune system is and what your gut microbiome is. So if you don't have a healthy gut microbiome, your immune system goes into overdrive, and that's where a lot of people die from. Actually, the immune system gets too excited. So the point is to stop making these breaks and let's try to keep the connections there. So this picture is taken off the deck of my son's house in Washington, D.C. And so we're looking, there's two inset pictures. There's this inset and this inset. And he grows, I don't think he has 400 square feet of space, but he grows a lot of vegetables. He's vegan, okay? That was hard to deal with, but they actually eat very well. They grow a lot of food. They grow a lot in containers. And this is our grandson, Miles. And picture was taken, I'll show you this video in a minute, but that was taken in April last year. And today is Miles' second birthday. Okay, so he's 2 years old today. What's important about this picture, this inset? Got your hands in it, right? Contact, you got it. And look at the reverence the person has for that soil, how they're holding it, how they're cradling it. That's what we need to do. We need to nurture. We don't need to suppress and kill. We got to be in contact. So I'll show you this quick, and I just got a couple more slides, and we still have a few minutes for questions, right? Are we going? Yeah. Right on time. Okay, good. So this is April last year. Miles loves gardening. He when I was there at Christmas time, and he goes, "Oh, nice compost." He pulls out handfuls of stuff, and he's just exploring. So a couple last thoughts here. When I started vet school, so we're going to have our 35th reunion this summer for our vet class. In the first week of school, we had a really good professor, and he when the class came in, he said, "You know, you're going to learn a lot of stuff here." You're still not going to know all that much when you go out. But you're going to see cases, and you're going to have things that go good, and you're going to have things that don't go so good. And he said, you're going to make mistakes. You're going to forget about something. You're going to not do something right. And you're going to feel bad about it. But he said, but I'll tell you one thing. For every mistake that you make because you didn't know, you make 10 because you didn't look. And I think that's really an important point, is we need to be out there looking all the time. What's happening? We make a change. What happens? Yeah. Okay, so this is it. The main points, connection. It's all connected. We're all connected. Let's not break the connections. Let's make the connections better. All the communities. Balance. Let's balance. Have balance in your life. And I say balance. You know, the scientific is good. It's very useful. But you can balance that with things that you feel, things that you observe. I think it's important to keep things, not get out of your thinking brain sometimes. We think too much. Sometimes we got to go out and just look at things and really take it in, because we're always thinking. The problem with when we're thinking is a lot of times we're thinking about not being there. We're thinking about the future or the past. And you really need to be there and take it in. The other thing is unity. Again, it's all tied together. We're all people have used this term, we're all in this together, and they're kind of referring to the people in the country or the people in the world. But we're all in it together, not only people, it's all the creatures, it's all of creation. And so don't do things because whatever you do to the creation, you do to yourself.